Problem number 12, we have a solution that is 0.045 molar in sodium chloride and 0.045 molar in sodium bromide. To that, we're going to add some solid 2 nitrate. And once again, they're asking me which salt is going to form first. So we have a solution that contains some sodium chloride and some sodium bromide. Right now, nothing's going to happen because all this is soluble, no precipitate forms. But then we take some solid lead 2 nitrate, so PbNO3, and we're going to just dump it into this beaker. And upon hitting the water, that lead nitrate breaks up into lead ions and nitrate ions, okay? And doesn't change the volume, which is very important because if the volume doesn't change, then we can assume the original molarities stand true. Nitrates, they're always soluble, so pretty much in KSP problems, we can ignore them. But what I really want to focus in on is that lead 2+ ion. Once that lead 2+ ion is in the water, it's going to do 2 things, or possibly 2 things. That lead can pair up with the chloride, okay, and make insoluble lead 2 chloride precipitate, or it can pair up with the bromine ion and make insoluble lead 2 bromide. So again, we have these 2 possible insoluble salts that could precipitate out. And again, whichever one has the lower lead ion requirement will be the first one to precipitate. So we're in that selective precipitation mode. I need to go through my 2 scenarios, calculate the lead 2+ ion concentration for each one. So I'm going to start by writing the dissociation equation for the 2 possible salts that will form. And one of them is lead bromide, dissociates into lead 2+ and 2 bromides. And I'm going to write the KSP expression. Lead 2+, bromide squared. And that's why I always like to write out the balance equation so you can see those coefficients, because coefficients, very important in K expressions, they are the exponents. Okay. Second scenario, is it the lead chloride solid that precipitates first? Again, 2 chlorides are produced, so that KSP expression is going to have a square on that chloride. Okay, so now it becomes a plug and chug. Plug in the KSP values for each one, plug in the bromide or the chloride concentration, and solve for lead. Alright, so for the bromide, 6.6 times 10 to the negative 6. This is KSP value. I don't know what lead is, but I do know the initial concentration, or the equilibrium concentration right now of that bromide, how much bromide is in that solution. I know we started with a 0.045 molar solution of bromide. So that's the molarity that we had to plug in here. 0.045 molar for that bromide, and remember to square it. There is no dilution occurring here because this problem, the way it was worded, this is the molarity after we've already mixed together the sodium chloride with the sodium bromide. So they're already telling me that end result. It actually saved me some work. And solve for the lead ion concentration. So lead ion concentration has a value of 3.3 times 10 to the negative 3 molar. That's how much lead is required to cause this precipitate of lead bromide to form. Let's compare that to the value needed for the lead chloride to form. Lead chloride has a KSP of 1.7 times 10 to the negative 5. Plug in the concentration of the chloride. which is 0.045 as well, and that is being squared. So the concentration of lead 2 plus is 8.4 times 10 to the negative 3 molar. And now you compare the two lead ion concentrations. You're comparing 3.3 times 10 to the negative 3, 8.4 times 10 to the negative 3. Pick the smaller one. The smaller value is the 3.3. So therefore, part A, which salt precipitates first? The lead bromide solid precipitates first. And how do you know? And that is because lead bromide requires a lower concentration of lead ion than the lead chloride. Okay. Part B, I believe it asks you, what is the lead ion concentration when the first salt begins to precipitate? We've already calculated that. That is at 3.3 times 10 to the negative 3 molar. Okay, so again, we've gone through our two scenarios. You calculate the equilibrium ion concentration needed to start precipitation of both solids. Whichever one gives you the smaller molarity, that's the precipitate that forms first. Now, if this was like a multiple choice question and or one of those very short FRQs, you could have answered part A without doing any calculations. And that's because if I look at these two KSP expressions, I'll notice that they look almost identical. They have lead to the first power and bromide squared, or the chloride squared. That negative ion is being squared. And so the only thing, and the bromide is 0.045 and the chloride is 0.045. So since this was identical molarities of the negative ions and they're both being squared, the only thing different are their KSP values. Lead has a KSP value of 10 to the negative 6. And, I'm sorry, the lead bromide has KSP value of 10 to the negative 6. And the lead chloride had a KSP value of 10 to the negative 5. Because all other conditions are identical, I could have just looked at the KSP values and predicted which salt was going to precipitate first. Whichever one had the smaller KSP value was going to precipitate first, and that was the lead bromide. It's 10 to the negative 6, whereas the lead chloride was 10 to the negative 5. So that 10 to the negative 6 value is the smaller one, which really means lead bromide is less soluble than lead chloride. So it does make sense. If everything else is identical, the one with the lower KSP value is going to be the one to precipitate first. So that's just a little multiple choice trick in case you run into scenarios in which things are identical and the only thing different is that KSP value. Go with the smaller KSP value, save yourself some calculations. But if they ask you part B, obviously you're going to have to do a calculation and solve for the molarity of the lead ion. Okay, now I want you to look at number 13. I want you to hit pause. You try this one on your own and come back when you have an answer. Go ahead, hit pause and work this one out on your own. Come back, check your work when you're done. Okay, so I go through my two scenarios. I got lead sulfate, break it up into lead ions and sulfate ions. I write out the KSP expression. I plug in the KSP value. I plug in the sulfate, and I get a lead ion concentration of 5.1 times 10 to the negative 7 molar in order to start precipitating the lead sulfate. I repeat with the lead chromate, and I solve for the lead ion concentration, and I get 5.7 times 10 to the negative 13. 10 to the negative 13, much smaller than 10 to the negative 7, so the first one to precipitate is the one with the lower lead molarity, and that's going to be the lead chromate. So letter A, the lead chromate is going to precipitate first, and then letter B, how much lead is needed, and it's that 5.7 times 10 to the negative 13 molar that we calculated above. Now, if this was multiple choice again, I could have asked you which salt is going to precipitate first. No calculation needed for 2 reasons. Number 1, each one of our potential salts breaks up into the same number of ions. Okay, I got 1 lead and 1 negative ion. And number 2, the concentration of that negative ion is identical in both of these scenarios, 0.035. So since I got identical conditions, the only thing that makes these 2 salts different is their KSP values, and the one that has the smaller KSP value, 10 to the negative 14, is going to precipitate first, because that 10 to the negative 14 means it's really insoluble, so it's going to be the first solid to form. Okay.